Now we will discuss measures of the center of the data. The two most widely used measures of the center of the data are the mean and the median. So the median, which is our middle number when you put them all in order, is generally a better measure of the center if you have outliers, because it's not affected by those precise numerical values of the outliers. Now, the mean is the most common measure of the center. So the mean is also called arithmetic mean or average. And in this course, you'll see two different types. You'll see the sample mean, which is read as X bar and written this way. And you'll see the population mean, which is read as mu and is this symbol. The median is the middle value once the data is put into order, and the value that half the order data are less than and half are greater than. So remember that the median is also the 50th percentile and Q2. Then the mode is the most frequent value. One other thing I want to go over is just a quick math review to understand what sigma notation is, as you will see it in this course. So if you're given a sequence, a sub 1, a sub 2, a sub 3, and so on, we can write the sum of the first n terms using summation notation or sigma notation. And this comes from the Greek letter sigma. It's capital sigma, corresponding to our S for sum. So the sigma notation looks like this on the bottom here. And on the next slide, I'm going to break down the pieces of this. So the left side of the expression on the previous page is read the sum, so right here is our sigma, the sum of a sub k from k equals 1 to k equals n. So the letter K is called the index of summation, or sometimes summation variable. And the idea is to replace K in the expression with integers 1, 2, 3 to the nth. And then you add the resulting expressions, arriving at the right side of the equation. So the bottom is where to start, the middle sigma tells us what operation we're doing, and the top is the end. So let's take a look at some here. So if you look at this top problem here, the way we read this would be the sum of the quantity k plus 1 squared from k equals 1 to k equals m. The next one is the sum of f sub I from I equals 1 to I equals m. And then this last one is the sum of f sub I divided by n from I equals 1 to I equals m. So now let's take a look at some example problems. So this first one, the sum of k squared from k equals 1 to k equals 5. So we're going to replace this k with 1. So it's going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Remember that we're starting at 1 with k equals 1 and then k to 5. And we add that up and we get 55. If we look at this next one, then we have j starts at 3 and then goes to 5. So it will be 1/3 plus 1/4 plus 1/5, and you get 47/60. Then with this one, we're starting at I is 5 and we go up to I equals 10. So we are simply going to do 5 plus 6 plus 7 plus 8 plus 9 plus 10 equals 45. And then let's look at this last example, which is the sum of 2 from I equals 1 to I equals 6. So when you look here, you're going to say, hold on, there's no I. So in this situation, you do 2 6 times. So 2 plus 2 plus 2 plus 2 plus 2 plus 2, and you get 12.